here x bar equal to average.
So you need to look at counting.
Yeah, you use count if for the proportion one. Yes.
How much? Between those two values. Yeah.
This is S, the standard deviation of the sample. So first I need the sample standard deviation, sample mean.
So can you put two criteria?
So for the first one, you need the sample size equal to 180. So the confidence interval, you need the standard error part, right? Standard error, that's your sample standard deviation divided by square root of sample size. And then the margin of error. That's the z value, right? 95% confidence interval, two-sided z value 1.96, multiply your standard error. So this upper, so the 95% confidence interval is x bar, which is 99.92 plus minus 0.665. So this is the confidence interval. You also can see that's between minus the margin and this plus the margin. So this is the confidence interval information here. So we answered the first question. The second one, what is the 95% confidence interval for the proportion of resistors? Meet the specification. So for this one, we need to know out of 180, the X, so what's the number of resistors that meet the specification. Okay. Specification count ifs. Okay. The range 1 from M2 to M. What's the bottom? So if you want one step to solve this problem, you need count ifs, but this time you all refer to the same column. This column less than 105, and also the same column data should be larger than 95. So we know the sample size n is 180. So the p tilt, right? You remember this one?
Is that not just from the end?
So you see, this is the formula. So what we need is the p tilt. So p tilt equal to this x plus 2. Divided by n plus 4. So since the sample size is so large, not big difference, you use p tilt or p hat, the classical one. If you take AP, you just use the x over n. So sample size so large is quite close. So once you have p tilt, you can calculate what we call standard error part. So standard error part, that's the without the z-value part. That's the square root of p tilde multiply 1 minus p tilde divided by sample size plus 4. And then you can calculate the margin of error. Or somebody, people say error part, margin of error. Since I want 95%, that's two-sided, so this z-value still 1.96 multiply the standard error part. So plus minus like 5.4%. And then the 95% confidence interval, that's, you see, use p tilde 0.83 plus minus 0.05. Make it switch. This one, the lower bound minus the margin of error. Upper bound plus margin of error. Oh, we can put see the percentage here. But one more thing on this one, the confidence interval. So we also have confidence interval for the mean. We can directly use the Excel formula. They have one called, I just put our margin of error part, equal to confidence. If you use z-value, you just use norm, confidence norm. Your alpha 95%, so alpha is 0.05%. Standard deviation, sample size. So it's just one step give you the answer. So basically, you can use this as a way to verify your solution. So I'm not suggested to use it because it's only two-sided. Okay. You also need to calculate standard deviation, the sample size. This alpha is 1 minus confidence level. Okay. If you need one-sided, you really need to think by yourself. There's no formula give you. For this confidence, this is the margin of error, calculate the margin of error for confidence interval. If it's a small sample size, they also have confidence, that's T. Okay. And the same thing, what's your alpha level? So this alpha, you add these two together, just 1 minus the level. Not as we calculate, we think it's two-sided, just half, alpha over 2. A little confusing, but just let you know there is the formula in Excel here. But with using it with cautious. Okay.